Well, great. I'm glad that you're continuing on in this series as we create a full game, relatively simplistic, but still a full game that will run on the mixed reality devices. Last week, we actually created this environment by bringing in all the prefabs that we needed from the mixed reality toolkit. We created this table with the 3 shells, which are these cubes, and with a P on the inside of the shell. Okay. And just so you can see it there, you can hide the mesh renderer and see the P underneath the shell. Now, this week, what we're going to be doing is creating the actual logic that runs the game. So having the computer decide which shell is the P going to be under, 0, 1, or 2. Now you might think, well, that should be pretty simplistic. Let's just bang that out, and we could. But I want to take the opportunity to split this out into its own logic. That way, if I ever decide to use something other than Unity, I could still have this code ready to roll. If I wanted to write tests against this, that I could without being tied to Unity. So let's go and open up Visual Studio. So I'm going to create File, New Project. And what we want to create is a class library. We could pick Windows Universal if we wanted to. And if we created that, you would need to make a subfolder. You'd actually have to make 2 different DLLs. One is kind of the stub for Unity, and then you make another one that you put into a special WSA folder underneath plugins, and that would be the Windows Universal one. And you do this if you'd want to like bring up the file picker or talk to some kind of Windows 10 specific functionality. Okay. For what we're doing, we're not creating any of that. So all I care about is running my test in Visual Studio. And so I'm just going to pick a class library.NET framework. Now I'm hopeful at some point we'll be able to use .NET Standard in Unity. That seems to be the path it's going. But for now, this class library.NET framework will meet my needs. So I'm actually going to go to my FMR folder. And for this, I'm just going to call it Core Logic. And I'm going to hit OK. We'll move this out of the way. And I'm going to rename the class 1 here to Shell Game Logic. And we'll rename the class as well. I'm going to add another project here. So add project. And this is going to be a test project. But I'm not going to use this unit test project because this is to be using the MS testing framework, and I want to use xUnit. So I'm just going to pick a class library.NET framework again. I'm going to call it Core Logic Tests. And I'm actually going to put it under the same folder as my main project. I'm going to manage my NuGet packages and browse and look for xUnit. So I want to grab xUnit, and actually I want to grab xUnit Visual Studio. So I want to install that one. And I also need to install xUnit itself. Let it install all of its dependencies. Alright, so we'll close down that. I'm going to rename this class to be Core Logic Tests. And we'll rename the class name. We want to be able to use that core logic. And so in order to do that, we need to add a reference to this project. Core logic. And so it recognizes that. Just to make sure we have xUnit set up correctly, we should be able to see a fact here. Hit Control Dot to bring in xUnit. And we'll just call this first test for now. So I'm not sure what I want to call it, but we'll say So I have an arrange act and assert. So what I wanted to arrange is my system under test. So I'm going to shell game logic is equal to, I'm just say create core logic, call that function there, and we'll go ahead and create that private method, and for now I'm just going to say return new core or shell game logic. So I think I'm going to have a method called like check for item. So I'm going to say bool result equals system under test check for item, and we'll pass in some item there, 0, 1, or 2, for example. So we'll pass in 2, and let's assume that's the right answer, and we'll say assert. Well, I think what I want to do is say that result should turn true. So I'll just say true and result. So if I did check for item and it's a match, then this should come back as true. So we'll save that. And of course, the very first issue is the fact that we don't have, have this method. So I'm going to hit control dot here and let it generate that method for me. And come back over here to shell game logic, and here we have it. Now I'm going to call this item ID. So check for item, pass in the item ID, and return true for now. Let's go back over here to our test. Control Shift B. We'll run the test. And we see it's passing. Okay. Now, something that this version of Visual Studio has that I use is something called live unit testing. So I come in here and say start. And what that's going to do is, as I'm writing code, it's actually going to continue to be running these tests in the background, and we'll get these check marks on the side. So this is only available in the enterprise version of Visual Studio. So chances are you might not have that, and that's okay. You should totally have this test explorer. In order to find that, it's under test, Windows, test explorer, or you can hit Control E T. So what we just did is we're doing red, green refactor. So red, it wouldn't even compile, and now we have a green returning true because that's all I'm doing is returning true here. And then we need to refactor it and actually make this thing do something correctly. So I'm going to go back up here to our shell game logic, and I know I'm going to need an array for my items that I want to check. So I need this stuff in memory. So I'm going to say int items, and then I'll need a constructor. We'll call that public int items. We'll need access outside of that most likely. And I'm going to say, help if I actually put these in the right spot, right? So it's an array of ints. But I'm going to say items equals new int of 3. Now we need to assign values to those items. So I'm just going to create a method here called create items, and we'll generate that method. And we'll say for int y is equal to 0, y is equal to 3, plus plus. Now I'm seeing that I'm using 3 here a couple different times. So I'm thinking I want to create a private int number of items and int number of items. Then get through here, number of items. And I believe I want this to be a read-only actually. So private read-only. So once it's set, it's there. I'm not going to be able to change it again. And let's say this dot number of items equals number of items, because we'll need it again down here. So we'll get rid of that magic number. And that's also going to mean that my, imagine as soon as I compile, my tests are going to fail because over here in my test, I'm not even using a value here. So I'm just going to pass in 3 for number of items. Let's come back here. We'll just say items sub I is equal to I for now. All right, we also want to be able to generate random number. So we'll create that method. And we're going to need a, let's see, private random rand. Now the thing is, in order to test random numbers, we're going to need to pass it into our constructor. So we're going to have to create a little bit of boilerplate code here in order to get some testing done. So I'm going to right click on core logic and say add new item, and it's going to be a class. I'm going to call it LMR random for learn mixed reality. And this is going to be a public class. It'll be an abstract class. And what I need to see is exactly how random is done. So I'm going to hit F12 here on random and see what we have. So I'm going to grab these methods right here. Copy those and paste them here. And we'll get rid of the comments. Okay, so these are going to be abstract. And now that I have that, I need to create another one. And I'm going to say, so we'll add another item, or I can just say class. And I'll just call this net random, as in .net's random. And this will be a public class. And they'll inherit from learn mixed reality random. I'm going to hit control dot so I can implement that abstract class. And I'm going to do a private random rand. So the thing I was going to set up over here, now this is simply going to be my base class random. But let's get back over here to my net random. So we have this is the real class, net random. Now all we need to do is call the methods against this actual random function. So I'm going to need a new constructor because we saw that it took in a seed value and it had another constructor that didn't take in anything. So we'll just say rand equals new random and a rand equals new random passing in the seed. Okay, and then for our next, we'll just simply say return rand.next and return rand.next min value, max value. Okay. Same thing for this. And same thing for bytes. And finally, we need to say return rand.next double. Now, there's no need to test, obviously, the .NET framework's random, so I don't care about that. We go back to our actual logic here. Now I need to do some inversion of control. So instead of me newing up a random object, I'm going to pass one in. So it's going to be learn mixed reality random. We'll call it rand. And this dot rand equals rand. Probably put that up a little bit further. Okay, so now in our generate random number, we can say what rand.next, 0 to begin with, and number of items is what we want. But we need to store that someplace. So let's create a private int item location. So which shell is this item located? And we'll set that. So item location. Now my check for item is going to say return what? Item ID is equal to item location. We need to come back over here to our test and actually pass in something here. Now I could just pass in new, let's just say new net random. And this should probably fail unless just by chance it happens to randomly pick 2. Let's see if we can actually get it to pass once here. And so there it passed that time. And you never want your test to pass sometimes and fail sometimes, right? So that's a bad thing. Instead, that's the reason why we created that abstract, is we could actually pass that in here. But simply passing in there is just not going to be enough for us. Instead, what we want to do is create a stub. And we're not going to get totally deep into testing, everything that's involved there. But we're going to create a stub, and I'm going to use a framework called mock or mock-q. So I'm going to come back in here and add manage NuGet references and look for mock. And we'll install mock to our test project. Now that I have it installed, I need to actually use that syntax. So I'm going to control dot to actually bring in using mock. And then we want this to be learn mixed reality random, because that's what we're actually mocking up or creating a stub of, really. We're a new mock of the same thing. And then we want to set this up. And so I know all I really care about is r.next. And this is somewhat getting to an implementation detail. But since I know all really I'm calling is at r.next, I can say rand setup, r for random, r.next, and 0, and that number of items, which I need to set. So we'll just say 3 here. And when we call that, what mock lets us do is say, okay, every time we call this, I want you to return this value instead. So always return 2, right? Now what that'll let us do is, instead of trying to pass that in, we can just pass in rand.object. So what this is going to do is, we're going to tell, and you see the tester passing now, because we're telling our shell game logic, when we're instantiating that, we're actually using this fake random, this abstract class, LMR random, learn mixed reality random. And we're saying, hey, if somebody calls the next function, passing in both the min and the max, make sure return 2. Because we know that's what we just set up here. We know that's the only method we're going to call on this guy. So that's all I'm going to set up. Now that is somewhat of an implementation detail, so if this ever changed, then our test will break, and that's usually not very good. But again, I'm not going super deep into getting this rolling. I know I'm not going to change that logic, at least I'm not planning on it. If so, then I'll remember to come back and modify this if I want to use floats or not use a max or whatever the case is. But for now, this is what I need, and that's what I'm going to do. If I go back over to shell logic, though, I don't want my regular client to be forced to pass in, like a new net random, So what I'm going to do is create a whole other constructor. So create another constructor here, And this one is just going to take the number of items, and it's going to call this the other constructor, and it's going to actually pass in new net random. So, and then also, of course, the number of items. So in my game, when I create a new shell game logic class, I would only need to pass in my number of items, and by default, I will actually create this net random. But this lets me test random numbers, knowing that I'm always going to get back the number 2, because that's what I set up in this test right here. So hopefully that made sense. If not, you might need to rewatch that and see if you can follow along. Hopefully it was clear. But if not, you might want to do some research around mocking, and mocks and stubs in particular is what we're doing here. And just to confirm, if I said check for 1, I would expect this test to fail now. And we can see it does. Similarly, if I said I want this to return 1 every time random is called, this should start passing again. Okay, so I'm going to change both of these to 2, just so it's consistent, and the idea is it's the second one, just easy to remember. Okay, now I need to name this test something, and you can name your test however. You should try to go with convention and stick with it. So I'm going to say, given the player selects the correct item on the first try, then check for item should return true. Now, there's obviously debates whether you should actually have method names inside of your test. Some people like it, some people don't, think it's kind of brittle. I don't necessarily put them in all of them, but this particular one, that's exactly what I'm checking. So I could just say could return true for that matter. I could do that, just should return true. So now we actually have a test, and we can look at it up in here saying, okay, given the player selects correct item on first try, should return true. And if that fails, we know that's where we need to start looking at our problem. Okay. Well, let's just do the opposite of this one, right? And so I'm going to actually copy this whole thing and paste it and say it should return false when they select incorrect item. We're going to say 1, and we want to assert false. All right? So when they come in and they pick the incorrect item on the first try, just return false. Perfect. Similarly, I have a little snippet here I can use. So I'm just hitting UT, which creates this fact for me. And I'm going to say, given player selects incorrect item on first try, and second try, should return false. And again, we're going to do our shell game logic system under test is equal to create core logic, and let's say check for item. So we'll do the wrong one there and say if not result. Then we'll check another one. Check for item 0 this time. All right. So we tried once. We got the wrong one because we know the right answer is 2. We tried 1. It's not right. Assuming it's not right, we'll then try the 0 one. Assuming that's not right, then we're going to come down here and make sure that we're actually getting false. So result. All right, so that way, if for whatever reason this changes and that becomes true, then it won't even go in here, and we're going to fail this test. Assuming that one works, it'll try the second time, and assuming that also came back as false, then we'll be good here. All right, so I have a couple of tests created. Let's get back to our logic and start thinking about how we would need to use this in the game itself. One thing is I was thinking about is if the user selects the item incorrectly and then they select the next item incorrectly and then they select the first item incorrectly again, their game shouldn't necessarily be over. If they keep selecting the same one over and over again, that shouldn't count against them. It should only count against them the one time they picked it. So there's a couple different concepts that I'm thinking about right now. One is this notion of strikes. So let's go and do that. Just to add in the total number of strikes that we could even have in the game. And since we're letting somebody pass in the number of items, probably need to pass that in as well. And same thing here. Because that way, whatever the game is that's calling this, if they want to say you have 3 items and 3 strikes, that's fine. Maybe you have 10 items, only 3 strikes. Then that would be an option as well. We will want to keep track of how many were missed. But this would probably need to be public because we want to make this available to our game to be able to check how many we missed. And we'll actually have strikes itself. So my current amount of strikes. So this is the total strikes I'm allowed to have, and these are the number of strikes I had. And a strike is when you have, just make it simplistic. Let's say we only have 3 items, which our game is going to have 3 items, 1, 2, and 3, and you picked the wrong one twice, right? So you picked, item number 1, you got it wrong. Item number 0, you got it wrong. And then, of course, the only one's left is item number 2. You pick it, and now you have a strike because you didn't guess correctly. But let's say you guessed item number 1, and you were wrong, but then you guessed item number 2. Then your points should be less, but it's not a strike against you. And points is something else. So we really need a score as well. But I'm going to hold off on the scoring for now. Let's take a look at the strikes some more. So we're going to need to modify our actual check for item, make them a little more complex. Because we need to know, did we already check this item for this turn, right? Because if we already checked the item for the turn, then we don't need to mark it against them. So, already checked is equal to what? So I'm going to have to actually have that associated to the item, which means I'm no longer going to be able to use an int for my items. I'm going to have to use a class. So up here in core logic, I'm going to add a class. I'm going to call it item. Be public. Of course, I'm going to need to know what item it is. So I need an ID. And I need to know if it's already been opened or not. So I'll just say already checked. We'll save that. Come back up to this. Instead of being an item or an int, we're going to make it an item. And items is going to be new item. In our create items, we're going to need to do ID is equal to that. And of course, we'll just reset each one to not have already been checked, so being false. All right, so instead of simply returning this, we're going to put that into an if. But before, let's go ahead and finish up our previous thought of already checked. So I'm just simply going to set that to items, item ID, already checked. Just so we have something to work with. Now we might refactor that out in a little bit, I'm not sure. But I'm going to say if item ID is equal to that, then we're going to return true. Otherwise, we'll return false. So we'll start there. And we'll run the test and see if we're still good. We're not. Well, I got build errors. Yeah, I never did add in our number of strikes because we added in strikes up here, total strikes, but we didn't put it back in our test. So let's do that. And we'll just say if you have 3 items, then you have 3 strikes. Okay, and we have every single test failing. Let's look at the test. And we're getting an null reference exception. I know what I did. Right here, when I'm creating this, it was an int, and we changed it from an int. And so now I need to say items sub I is equal to new item. Now when we save that and run them all, we're all passing. Great. Now before we return false, I want to say if not already checked, the missed count I want to add to it. And I want to say items ID already checked is now true. And we're ultimately going to have to raise events. So our game logic, the actual game controller inside of Unity, will be able to understand what's going on. So basically I want to do like a raise event match not made. So let's go to our test and create another one here. So we'll say given the player loses round, should have a strike count, and it should be 1. Okay. So our system under test is going to create that. So we'll say we're going to check for item 0, and then check for item 1, and then check for item 2. So we're expecting that to return false, and that'll return true. I'm going to say 1 strike count. Strikes. Alright, we're seeing we're failing because we're doing missed instead of strikes. Let's go back over here. And actually, I do want 2 different things. So missed is when they missed it, and strikes is when they missed too many. So let's go and introduce scoring real quick here. And I only care about scoring if it's a match. Now this could be a match because they got on the first try, the second try, or their last try, which really means they shouldn't get any score. Because the way I look at it is this. If you get on your first try, you get 3 points. Second try, 2 points. Third try, 0 points. Okay, and it could be maybe you'd want them to have 1 point on the second try. I don't know. So however you want to do it. But for me, this is how I'm going to do it. I'm going to do 3, 2, and 1. So I'm going to say score is equal to the number of items minus miscount. And that way, if we have 3 items and we miss 1, then the score is going to be 2. If we have 3 items and we didn't miss any, the score is going to be 3. If we have 3 items and we missed 2, which means that this is our last try, our score is going to be 1, but we want it to be 0. So I'm going to say if score is equal to 1, we're going to add our strikes. And we also actually want to raise the event here of no match. And we already see that the tests are passing again. So we'll figure out how we're going to get the score out to the game controller in a little bit. So this miscount shouldn't be public, I don't think, because there's no reason for my test to know how this thing's working internally or for my game itself. So I'm going to change this to lowercase, just rename it and make it private. Get rid of those comments. So let's go back to our test and let's create another test here. So let's see, we'll say given player loses round, it should have a strike count even if reselecting previously selected item. So system under test, we're going to check 0, and then we're going to check 1, and then we're going to check 0 again, and then we're finally going to check the right one, which was our last time. Let's do another one here. So given the player strikes out, then wins on second try, and strikes out again, then the strike count should be 2. So system under test. This is going to be strike 1. So check for item 0. I'm going to grab the same ones up here again. And strike 2. Actually, this is, I said right on the second try. All right. And then strike 2. Now we'll just kind of double that guy up in here. And so at this point we should have 2 strikes. And I imagine this is going to fail because we've not set up any of the logic for this yet. Okay, so let's do that now. First, I want to get rid of this comment here. Don't need that. And in fact, I'm going to go ahead and take him out and check it down here. But with that already checked, he never gets reset to false. So that's definitely an issue we need to resolve. So once we've found a match, we want to close the shells. So I'll just say close items. And this is going to be very similar to the create that we had, but we're not newing anything up. We're just simply setting the already checked to false. So let's see what the return value we actually got back. So we expected 2, but we only have 1 strike. So we got it wrong this time. That'd be strike of 1. We got it right this time. We got it wrong this time. So let's just simplify this real quick. And it didn't help, which I didn't figure it would. But I do always, before I make something super complex, I just want to make sure we'd already tested that above, but just to make sure we're all good there. And in fact, I think I will just remove it, just so it is simply testing what I need to test and no more. So of course our issue is the fact that we're doing this based off missed count, and we're never resetting missed count. So we need to have a way to reset our items. So I'm going to create a new method here. And let's see, we're going to say, I guess we can do a couple different things. One is if strikes is greater than or equal to total strikes, then we want to raise the game over event. Right? And we'd also want to go ahead and reset our strikes to 0. Likewise, we want to go ahead and set our missed count to 0 as well. We'll save that. And it's going to be the responsibility of the game to call reset items when they're done. Because it could be, you might think maybe we just do it at the very end here to call reset items, but in case they're running animations or have anything else going on, we really want them to call it. So here in our test, we'll do the same thing. So set reset items, reset items, reset items. We'll save that. Of course, we're never calling this reset items at the very beginning. So inside of our constructor, let's actually call reset items here. That way we make sure that missed count starts at 0. So I'm going to put a breakpoint here and go to my test and say debug test. So we added to our miss count. Second to our miss count. Okay, so number of items is 3, miss counts 2, scores 1. Okay, so we're going to add 1 to our strikes. Great. Now we're going to close the items. And that's just simply going to make that already checked. And make that one already checked. And that was already done. Okay. And then we did find a match. It happened to be the very last one. So we're going to reset the items. 1 strike. Total strikes is 0. Okay, that's a problem. Strikes back to 0. So our total strikes is 0. So we'll close that breakpoint, let this thing run. Go back over to our game logic. We'll just stop the debugging. So we're going to say this dot total strikes equals total strikes. Simply missing that line of code and all should be well. And it is. Well, since we actually put in this game over event, a comment for here, let's actually create a game over event that can be called and then test against that. So we'll say given player strikes out, then the game should be over. Create core logic. And be able to do something like game over. And we're going to pass in some parameters to that. We need to do something here. So I want to make sure that an event is called. We're going to create an event. We're going to create a game over event. And if we hit 3 strikes here, we want to raise that event. And I want the event to make sure the event got called. So I'm just going to create a Boolean here called called. And just regular event has typically an object and event args is typically what will come back with an event. And so we can actually have something, a method here. All I really care about is that called, so we can just get rid of the braces and say called equals true. So assuming the game over happens, called will get true, otherwise it's going to be false. So down here, we're going to say assert true was called. So in order to make the game over actually happen, of course we need to actually call some things. So let's copy this guy as a starting point. And we'll say strike 2, and strike 3. All right, so we save that. We're not compiling yet, so let's go back over here to our logic. And I'll just say public event handler, and game over. Why not? I think game over should be a good event. We'll save that. And our test is failing because it was never called, and it was never called because we didn't actually call the event. Down here where our comment was, raise the game over event. We actually want to do that, so we want to say game over dot invoke, and this, and event args, not event handler, but event args empty. Now, if nobody subscribes to the event, that could be null. So we want to do a null check and close that out with a semicolon, of course. Let's save that. Now our test is passing. So our game over event is getting kicked off if our strikes is greater than or equal to our total strikes. And we're resetting our strikes, so that's good. Let's look at some of these other events we talked about, just going through here that we want to raise. And there's probably more we want to raise too. But we have an event for when no match was made. Another event, no match was made. Now, we'll need to raise an event here for if a match is made. Right? Because if we got a score of 1, that means that we found in the very last try. And so we didn't really get a match. Even though it really is a match, it's not a match because we got on the last try. But if we got on the first or second try, then we do need to raise the event so the game can know that, hey, a match was made. And of course, if the match wasn't made at all, if it's not the third time, then we'll just raise the event match not made down here. So let's I'm going to create a couple event classes here. Okay. So if we make a match, I want to make sure that we can get the ID and we can actually get the score back. And we'll also do a no match event args. And for this one, I want to know, okay, if we didn't get a match, was it a strike? Because I need to know whether that was a strike when we didn't get the match or we just didn't get a match. So let's go ahead and create those events. So we have public event, event handler, match made, and public events, event handler, match not made. And to our test, finds a match. Let's see, should raise the match found event with an ID. So we'll say, let's see, ID set, do a false. Okay, and we'll say match made. Yep, so that's just object sender event args. So right away, that's not what I want. I want to use my event args up here, which means I need to say match event args and no match event args. Right. So by passing my event arg class as a generic to this event handler, that means now when I say plus equal, I'm actually getting my match event args, which is what I want. So I'm actually going to take that, delete it, and do that. We'll say ID set is equal to e to ID. It's greater equal to 1, or rather the 0. So we get the right answer to begin with. True, ID is set. All right, so we're just simply saying ID should be ID and it shouldn't be. It should be greater or equal to 0. And match made's not getting created. But while I'm here, I'm going to do the same thing for match not found. So given player doesn't find a match, should raise match not found with is strike false. So let's see, we'll say is strike is equal to false. And we'll say match not made. We got our no match, so that's good. Enter. Grab this guy. That. And we're just going to call is strike is equal to e is strike. And there's a check for item incorrect. True is strike. Alright, so these are the two tests we want to make pass. And both of them are going to be failing because we're not raising either the match made or the match not made. So let's go do that. We'll say match not made. Invoke. And no match event args. Is strike is true here. And likewise down here, but this one should be false. And I believe I got my test. Yeah, let's change that to true here and false here. Because we want to make sure our strike was false, and it should get reset. It should get set to false here. So that worked. Good. Now we need to raise our match event. So match made. We're going to invoke that. So we're going to set that to items, item ID, .id, and score will equal score. And we can see the test passed immediately. Now let's go ahead and create another test for this guy, but this time we want it to be true. Doesn't given player strikes out. Should raise match not found with is strike is true. We'll say false, and we'll say true, and we'll save that. And we don't have the right condition in here, so let's save that now. And now we're passing. Perfect. So there'll be some more events we need to create. So let's go and do that. We're going to need an event when we want to start the turn. So we're going to say start turn. And handler start turn. That way when the game will know when the turn should start. And we're going to want to do that. So once we check for the item, let's do start turn invoke. So let's go ahead and create a test for that. So given player checks an item, the start turn event should be raised. And true called. Very good. Need to make it, because you're only going to start the turn if you got the answer correct. Whether you got it right or you didn't get it right, the point is you actually found it. So now it's time to start the new term. Next, we need a couple of hooks inside of our reset items. So the game controller in Unity is going to be calling this guy, and he's going to be saying, okay, hey, the user just selected the first item. Do we have a match, yes or no? We want to add some hooks in here that our game controller will be able to tie into if it wanted to. So for example, we want to be able to raise an event for item reset. Like, hey, we're getting ready to reset this item. And likewise, we would want to raise the reset complete event. And what I need to do is actually move this generate random number into reset. So let's go ahead and create those events. Say item reset, meaning we're getting in there, and then reset complete when we're done. Kind of add those hooks. And similarly, we're going to need some events for our check item, right? We want to know when we're starting the check item, when we're done with check item. So we'll just say checking item and selected item because we're done. Now we're going to want to have the ID for those. Let's go, before we go do that, let's go and raise, let's raise them down here. First of all, we need to raise the item event. So item reset, invoke this event args.empty. And likewise, we need to do the same thing down here for reset complete, but it's reset complete. Same thing for check for item. We're going to say checking item, invoke. And I actually want to pass in that item ID to this. So we need a new class here. And I want to pass in ID to that. So we need to actually create this class. We call it item event args. Come up here, public class, event args, and I want the ID, so I'm going to grab this ID here, paste him up there, and then make that class inherit from item. So match event had the item ID, but we just made an item events arg that only has the ID, and now match event inherits from that, so he has both ID and score. Alright, so let's go back to our check item. So at the very beginning, we're checking the item. If we didn't make a match, then we raise that event, passing in that we struck out. If we did make a match, then we go ahead and raise that event, passing in the ID of the item along with the score. And regardless if we made a match or not, since we finally selected the quote-unquote right item, we're going to tell it that we can start the next turn. So we need to actually add in a selected item here. And the selected item needs to, of course, be using item event args. As should checking item. Alright, so let me just remove these comments since we're actually just raising the events now. And this one gone. Okay, so let's add in some tests for those events. Okay, so given the player selects an item, it should raise the checking items events. So okay. And so as long as our ID is being set, something greater than or equal to 0, then we should be good. And of course we're doing that just for checking on the item. Trying to make sure that it was actually called. Well, not checking item, but check for item, please. Alright, I'm going to copy that and do a similar test. We'll say select right item. Should raise the selected item event. So we'll change that to 2 since it needs to be the right one. This here needs to be selected item. And just to make sure that we're still good there, I'm going to come in here to this and comment out selected item. Hit save, and I expect that test to fail. And it does, so we're good there. Okay, now we're passing again. Great. Alright, so let's do the same ones for our reset. Actually, reset items, I believe. And equals that. Item reset. Get rid of this. Okay, same thing as usual. Similarly, exact same thing, except instead of item reset, it's going to be reset complete. Reset complete. Just now feel pretty confident that the logic in here works the way I want it to. If I missed something, then now I can create a test for it and know if it's actually working or not. Now let's actually change our, double click on properties here, go to our build, I'll go over to Unity, right click on assets and just say show and explore. So go to the plugins folder. I'm just going to copy that folder name, go back into Visual Studio, and instead of outputting the path to bin debug, I'm going to output it directly into the assets plugins. Okay, so we'll save that, and I'm only doing that on the core logic, not core logic test. So my test project will never go to Unity, but my core logic will. So now when I hit Control-Shift-B, we should go over here to Unity, and it's recompiling because there's going to be a plugin in that folder now. And so now we actually got into the plugins folder. We can see the core logic DLL here. So we're going to wrap up this rather long session by making sure that we can actually call this guy. So I'm going to go to my scripts and just create a test script real quick. Call it test plugin. We're going to open him up into Visual Studio. All right, so now that Visual Studio is loaded with our test plugin, what I want to do is just say core logic, shell game logic. We just already see it's working. So up here we can just say using core logic, and we can say shell game logic equals new shell game logic. And what do we want? We want 3 and 3. And of course we could say, check for item 2. And just because we can actually say debug.log and since I'm using the .NET 4.6 API, I'm able to get this nice syntax here. And so we'll see. It may be true, it may be false. No idea, because this is using the random one. But let's go actually run and look at the console. We don't see anything because we didn't actually put the script on anything. So let me just drag this test plugin on top of directional light, because I'm just going to remove it anyway. So directional light now has the test plugin. We're going to hit play, go to our console, and 2 wasn't right. So checked, got to return false, but it's talking to our plugin, no problems. So I'm going to go ahead and delete that script from the directional light. And with that, I'm just going to wrap up this second part of the tutorial. It went pretty long, a lot of detailed stuff, but this is the core game logic for this. And if you're making your own, maybe you want to do the tests, maybe you don't. It's totally up to you. But now I have confidence that if I want to go in there and change something, that I'm not going to break a bunch of things. And if I do happen to break something, then it's going to show me I missed creating a couple tests, and I'm going to create those tests. But the actual process of creating a Unity plugin is pretty straightforward. You can create a .NET class, and as long as you're not using any Windows 10 specific things, then you just shove it straight into the plugins folder. If you were using Windows 10 specific things, then you could right click inside plugins and create a new folder called WSA, and you'd create 2 DLLs. The first DLL would really just be a stub, and that would go here under plugins, and it would be a full-fledged .NET plugin, but then you would create a Windows specific plugin that had the exact same interface, and you would put that into WSA. But again, we're not doing any of that, so we're just simply putting the plugin right here into the plugins folder, and it's working well. Next week when we come back, we're actually going to create a game management script to work with our game logic. And it'll be a whole lot quicker than the session this time around. Well, I hope you have a fantastic week, and I'll see you in the next video.